When you create a database and then create tables and then work with the data itself in that database, all that information is stored within a single .mdf file that resides on your computer's hard drive. However, there's a layer of software, a Windows service, that manages your interaction with the databases on your computer. It makes sure that your data is available, that it's secure, and it provides network connectivity from other computers if you desire that. This process runs in the background and it's always available waiting for your commands. And I wanted to start here because up until now we've really only been talking about the structure of the database and the data itself, which, as we just looked at, is just one aspect to SQL Server 2005 Express Edition. The SQL Server service or process is extremely important because it's the gatekeeper for your databases. When you start to consider how it is that your database will be used within your application and how users will connect to it, this distinction becomes very important. So what are your options when you start to consider how your application will communicate with the database? What if you need each user to have their own copy of the data so that there's no sharing between the users? Or what if you need users on different machines to all share the same data through the network? So there are two basic connectivity scenarios that the Express edition of SQL Server 2005 supports. Like all other versions of SQL Server 2005, you can allow other computers on a local or global network to access the data and the database objects contained within the MDF files on your computer. In this scenario, all the users can work simultaneously with the same copy of the database. They're sharing the same data, so if one user makes a change to a given database record, all the other users will be able to see that change as well. Now, in order to protect the integrity and the confidentiality of the data as well as the database's objects, a measure of security is employed by SQL Server to authenticate each user. Once each user is authenticated, meaning that they can prove their identity through the use of maybe a username and password, for example, then a group of permissions are granted to the user, authorizing the user to perform certain actions while interacting with the database. We're going to talk more about concurrent multi-user access as well as multi-user security in just a moment. The second scenario is unique to the Express edition of SQL Server 2005, and it allows multiple users on the same machine to each work with their own private version of the database, their own copy. These are called user instances. And the benefit of user instances is that it's very easy to enable because you don't have the same authentication and authorization concerns. So I want to stress that this scenario applies when you want to allow one or more Windows user accounts on a single machine to access the database, and the users will not need to share the same data. So if one user makes a change to a given database record, none of the other users will be able to see that change because they have their own private personal copy of that database. With user instances, securing the database becomes much more straightforward. If you're a user on the local computer, you automatically have all the rights you need to do whatever you want to do with the database. Since each user on the computer gets his or her own private copy of the database, they can do anything they want. They can delete things, they can change things. After all, if they try to do something malicious, they can really only hurt themselves. So user instances rely on the Windows operating system's built-in authentication and authorization mechanisms. So how do you tell SQL Server that you want to allow concurrent multi-user access versus user instances? Well, it's actually really simple. You don't have to change anything about SQL Server per se. It supports both of these scenarios. All you really have to do is just change the application's connection string. The connection string is a series of name-value settings that ADO.NET uses to try and locate and handshake with the database. Among the various settings you can configure, the user instance setting determines which of the two scenarios you want to enable. If you set this equal to true, then each user will get their own private copy of the database. Setting it to false, and all the users who point to the database will be sharing the same instance of the database. Now, behind the scenes, each time SQL Server receives the request to enable user instances via the connection string, SQL Server checks to see if that user already has a private copy of the database, and if they don't, then it creates a private copy of the database as well as all the other tables and settings that SQL Server uses internally. But primarily for our purposes, it creates a private copy of the database and uses the original copy of the database that was installed on the computer. Again, this happens behind the scenes, and the user might experience a short delay the first time that they run the application, but otherwise it's pretty transparent. Now, one last comment about user interfaces before we demonstrate how they work. When you create applications using other Express Edition tools like Visual Basic 2005 Express Edition or Visual Web Developer 2005 Express Edition, and you create a data source object, which then creates a connection string in either the app.config file or the web.config file, by default, the connection string they create enable user instances, so it sets it equal to true. And the reason it's set up this way is to enable the most secure scenario by default, then allow you to open up concurrent multi-user access only if you really need it. To demonstrate how user instances work, I've created a small example called SQL User Instances VB. Even though this is created with the Visual Basic 2005 Express Edition, I wrote absolutely no code, so you could do the exact same thing with the C# version if you are so inclined. Essentially, the only thing I did was create a database, which I called user instances vb.mdf. It has one table called sample table and just 3 fields: sample ID, which is in data type int, sample data, which is a varchar 50, and more sample data, which is another varchar 50. The next thing I did was I went to add a new data source, which pointed at my new database file, which opened up the data sources window. I simply went to the sample table, I selected data grid view, and I dragged and dropped that onto my design surface, which automatically created not only the data grid view itself, but also some of these other objects here on my form, like the sample table binding navigator, which allows me to navigate through the records, add new records, delete records, save the changes I've made, and so on, as well as a table adapter object and a binding source object. Now, the most important aspect for our purposes is the app config file. Whenever we created the data source object through that dragging and dropping technique that I described, it automatically created a connection string which is modifiable here in my app.config file, and you can see that it automatically created this SQL User Instances VB connection string, and you can see at the end of the connection string we have our user instance setting set by default equal to true. Okay, so we could change this if we wanted to and enable multi-user access from the exact same copy of the database, but we want to show how user instances work. So we're going to leave this equal to true. After I got the application working, I made sure that it worked. I went to the build and selected publish SQL User Instances VB and put it into a deploy folder on my C drive, so you can see that we have the SQL User Instances VB application. So let's go ahead and run the setup file that it created for me automatically. And now that I've successfully installed the application, it'll try to run it. There's absolutely no data in here, so we'll shut this down for now. What I want to do next is I want to go to my computer. I'm going to right-click and select Manage. Or I can go to to the control panel. This is a little more user-friendly. And go to the user accounts. Either way, I can create a new user account, which is ultimately what I'm trying to do here. And I want to create a new account. We're going to call this sample user. And for simplicity's sake, I'll just make this an administrator. Ideally, we'd make this limited, but I want to do some scrolling through the file system. So we're going to make it administrator, and we're going to select create account. You can see now we have our sample user. I'm going to go ahead and shut all this stuff down. And we're going to shut down this folder and this as well. And let's do this. We're going to log off. Actually, what we'll do, instead of just doing that, we'll go ahead and restart the computer. And after we've rebooted, you can see we have our new user, the sample user. Let's go ahead and log in as him. And let's try to install our application for this user as well. We'll go to the Windows Explorer, My Computer, find the Deploy folder. Let's get rid of the Take a Tour. And we'll go to Setup. Click Install. It'll install the application for us, and we'll try to launch it. Now, the first time it's launching it, it's creating our own private copy of the database. And so just to make sure that this works, let's do this. Sample data, we'll type in hello from sample user, and then we'll hit the Save button, and we'll close down the application. Now, let's do this. Let's take a look at the documents and settings and find those database files so we can see where it actually copies this particular user's version of the databases to. Now, what we need to do, because since we're not seeing all the files here that are actually available, is go to Tools, Folder Options, go to View, and we will show Hidden Files and Folders. We'll also get rid of this Hide Extensions setting. I'll click Apply, and actually I'm going to hit Apply to All Folders and click Yes. So now we're going to see all the folders that were previously hidden. Let's take a look in the Local Settings folder, and we'll go to the Apps folder, and we'll just keep drilling down. We'll choose Data, and there's going to be some really weird looking folder names, but we'll just keep drilling through them. We finally come to the Data folder, and now notice that we have a user instances vb.mdf and a log file as well for our database. Now, since we're an administrator on this particular user, I can go to the Bob folder, which is the other login. Ideally, if you are enabling least privileged access, and not every user is an administrator on the machine, but they only have local access to just their own files, then this the scenario makes a lot more sense. But we're going to do this anyway. We'll go to Local Settings again, to the Apps 2.0. Data, we'll just keep drilling through, and we find another copy of user instances vb.mdf. So to prove that we're working with two different instances of the same application, let's do this. This time we will hit log off, switch user. We're going to select Bob as the user this time, and we're going to run our application and see if we saw the same record. So let's go to our LearnVisualStudio.net SQL User Instance VB application and see if we see the record that we input from the previous user. And when the application comes up, there's no data. So the record that we created whenever we were logged in as the sample user didn't propagate to this database. Very good reason why, because it's a whole different instance of the database, a whole different copy, as we witnessed as we went through the Windows file system and saw where it actually stored those copies at. Okay, so that worked for user instances, but what if you wanted to disable user instances? How would you go about doing that? So in other words, you want to allow multiple users on the same computer to be able to access the same instance of the database. Well, as you can see here, I have a new project called SQL Multi-Users VB. Again, it's exactly like the previous example in every way. The only change that I made was in the app.config file. I went to the connection string setting to the very end and set the user instance property equal to false in this case. Then I built the application, and I deployed it a little bit differently, admittedly. Let me go ahead and close this down and show you what I did. Let's open up Windows Explorer. I simply went to my projects, multi-users, and went to the bin release directory and copied all the files out into a directory on my C drive called SQL Multi-Users VB, and then simply ran the application. And you can see I've already done this once, so I logged in as Bob, ran the application, wrote a record, logged out, logged in as the sample user. So I switched the user to sample user and then ran the application. Let's go back here though, and wrote another record so you can see we're sharing the same instance. Additionally, whenever I go now to the SQL Server Manager Express Studio, that we automatically get the database attached to our instance of SQL Server Express. So we can open up and work with it and so on. But the key here is that both users are using the same instance of the database as opposed to their own private instances of the database. And we enabled that simply by changing the connection string property. So now let's take a look at the first scenario we described at the beginning of this video, concurrent multi-user access. To enable your applications to utilize this, you have to do two things to the computer that will host the database. First, you have to create logins and then assign roles for the database using SQL Server Management Studio Express. Second, you have to configure network connectivity, which by default is turned off for security purposes. Also, if your computer has a firewall, you have to create an exception for SQL Server so applications can make requests on certain ports and not have them rejected automatically. So let's start with login and roles. Each login identifies a single user, ideally. Now, I've seen instances where multiple users or applications use the same login. It's not really an ideal situation. You usually want some granularity so that over time you can change the permissions for individual applications or users if need be and not affect all the other users. But back to the point, each login then has one or more roles associated with it. Each role grants permissions to do something on a database. We'll come back to the thought of roles in just a moment. But what is a login? Well, really, it's just a way of authenticating someone or something. It proves that they are who they say they are. In SQL Server 2005, there's two ways that we can determine this. If your application is running within a private Windows network, like at a company, then SQL Server 2005 can use each user's Windows login account to determine who they are. This is the preferred way to configure SQL Server for use because it relies on Windows' existing authentication mechanism. However, if this is an application that resides on a more public network like the internet, then SQL Server must manage its own authentication. You have to create usernames and passwords for each user, and this is called mixed mode. Regardless of the authentication mechanism, whether you're using Windows mode or mixed SQL Server mode, you must next decide what permissions are available to each login. Now, you could go user by user and assign permission by permission, but that would take a long time if you had a lot of users and permissions to configure. Instead, you can use roles. Each role has a set of permissions already defined, then you simply assign roles to each login, which makes management a lot easier. Now, SQL Server comes already with some built-in roles like sysadmin, or rather system administrator, and that role will allow you to do anything across the entire plethora of databases that are hosted on that particular server. You can create new databases, you can create logins and assign roles. You have essentially the right to do anything across any database. Another role would be DB owner, somebody who is responsible for a single database on a given server. Within that database, the user can create and delete tables, create other database objects, and interact with the data itself in any way. But then again, limited to a single database. To further restrict permissions, you might have a DB data writer who can both read and write to the database's data, but not be able to change any of the database objects like tables or stored procedures. And then probably one of the most restrictive of the built-in roles is the DB data reader, who can essentially just look at the data, is authorized to look at the data, but can't make any changes to it. Now you can decide which of these to use within your applications as you start assigning roles to the various to the various logins, people who you're going to let and allow to use the application. If the built-in roles aren't enough for you, you can always create custom roles and define which permissions are available to those custom roles. So you have that option. So to demonstrate how to create roles and logins within the SQL Server Management Studio Express, I've popped it open, and what I want to do is create a login and then assign that login the DB owner permissions on the My Company database. So let's start by going to the server and clicking the security folder. And you can see that we've already got several logins. Most of these are built-in logins, and you can see that they are either used by SQL Server internally, or in the case of the Superman role, is how we log in using the local Windows account. But we want to create a login so that somebody can log in to my database server over the internet. So we're going to create a mixed SQL Server managed login, and to do that I'm going to right click and select new login. I am going to create a login name, and I'll just happen to call it Bob, and we're going to switch from Windows authentication, which I would use again if I were only going to access this over my private network where I had a domain controller, Windows domain controller, login, all those kinds of things. We're going to let SQL Server manage this since we are publishing this out to the internet and want to be able to access it remotely. And we will create a password. So I'm just going to type one in here really quick. Enforced password policy looks good. Enforced password expiration looks good. We're not going to require that the user change it at the next login. We need to set the default database, what the user will be logging into automatically. We're going to set that to My Company. And that's about the only options we'll need to change. We can, if we wanted to, for example, make this person or this login a system administrator, we might go to the Server Roles tab or page and then select, a more server scoped role for this particular login, but we're not going to give this particular login any of these system level options. Instead, we're going to assign this login the role that will allow it to be the DB owner for my database. So now we're going to go to the databases, find the My Company database, and scroll down until we find the security folder for the My Company database, and open up the users folder and right click on users and select new user. And here we're going to tie a login that we created with a role or one or more roles. We're going to give this collection of a login name and the roles that it's assigned a name as well. In this case, I'm going to call it the same thing. I'm just going to call it Bob, and then I'm going to click the ellipsis under login name and choose the browse button, and you can see Bob is one of the listed logins that we created just a moment ago, and I'm going to click OK and OK. And then what I need to do is find the role membership, or the role that we want this user to be assigned to. And we can assign him and give him multiple roles, but we're just going to make him the DB owner and then click OK. So to really test that this works, we're going to need to access this computer from a different computer, use the login credential information that we created at the server level, and then make sure that that login has the DB owner role so that it can make changes to the My Company database. So that's a great segue into our next area of discussion. Now we want to look at and demonstrate how to configure network access so that users on other machines can access SQL Server on this machine and access the resources, the databases that are managed by this instance of SQL Server. So when you install SQL Server 2005 Express Edition, by default, it's not configured to be accessed over a network connection. The reason why it's set up this way is to enable the most secure scenario by default, which is to only allow users on the same computer as the instance of SQL Server to access the data, but then allow you to open up network connectivity if you really need it. And the way that you accomplish that is through the use of the SQL Server Configuration Manager. Let's take a look at that right now. To open up the Configuration Manager, we'll go to Start, All Programs. We'll find Microsoft SQL Server 2005's folder, the Configuration Tools subfolder, and then SQL Server Configuration Manager. So the first thing that we need to do whenever we look at the Configuration Manager is decide whether or not we're going to use the SQL browser service. The benefit of having it turned on is that users that are connecting remotely don't have to specify the port in their connection string. But it is a security best practice to not run the SQL browser service. If you turn it off, then it eliminates the need to listen on a UDP port, reducing the attack surface of your SQL Server instance. So let's go ahead and select it and then click the Stop Service button. The next thing that we'll want to do is configure which protocols we want to enable and allow connection on. So we're going to allow connection on TCP/IP. As you can see, by default it's disabled. The only thing that is enabled is shared memory, which makes sense because by default SQL Server only allows local connections, and we have to configure it to open it up to network connections. So let's go ahead and enable TCP/IP by right-clicking on it and selecting Enable. And it's really as easy as that. We'll have to restart the service, and we'll do that in just a moment. But what we'll probably want to do is also take a look at the properties, specifically the IP addresses tab, and make sure that we've got our IP address for our computer specified there. Ideally, we'd have a static network IP address for SQL Server so that there is some consistency whenever our users try to connect and they don't have to change connection string every time. So just one thing to keep in mind there. Go ahead and click the OK button, and now what we'll want to do is go back to our services selection on the left-hand side and restart our SQL Server Express process. And this could take a few moments. If we encounter any problems while stopping and restarting the service, you can always reboot the computer. So to get to the Server Configuration Manager, we'll go to Start, All Programs, go to SQL Server, Microsoft SQL Server 2005 folder, the Configuration Tools folder, and find the icon for SQL Server Configuration Manager. And so one of the first things that we need to do is determine whether or not we need the SQL browser service to be running or not. So let's take a look on the left-hand side at the services that are currently running. You can see that I have the SQL Server browser running right now. Now the benefit of having the service run is that the users connecting remotely won't have to specify the port in the connection string. Also, it allows applications like SQL Management Studio Express to be able to access your database because it uses UDP in the background. But it's a security best practice to not run the SQL browser. It reduces the attack surface area by eliminating the need to listen on a UDP port. So that's really up to you and what your intent is. For our purposes, we're going to leave it running, but if you can get by without it, you should turn it off. If you intend to use Management Studio Express remotely from a different computer, you'll have to leave it on. The next thing we'll do is go to the configuration protocols for SQL Express. You'll note that by default we have shared memory enabled. The rest of the protocols are disabled, but we want to enable TCP/IP. I'm going to right-click and select Enable. It says that the change won't be made until we restart our SQL Server service. That's great. Before I do that, though, I want to take a look at the properties. And the only thing that's really important in the properties tabs is making sure that your IP address is set correctly. Now, ideally, this computer has a static IP address, and so you would put that IP address here and make sure that it shows up correctly. Let's go ahead and click OK and move on to restarting our services. To do that, I'm just going to right-click and select Restart. You could also just restart the computer. And so if you run into any problems, the service won't restart for any reason, just go ahead and reboot the computer and it'll all work just fine. If you run into any problems with connectivity, you may want to look here and make sure that the services are in fact running. And if they're not in start mode automatic, you may run into some problems there. If you need to work through some of those issues, I would encourage you to take a look at the help or take a look at MSDN that's available from the Microsoft.com website. So just that since we've configured the network access within SQL Server doesn't necessarily mean that we're all ready to go. If you're using firewall software, you're going to have to configure it to allow requests. And in the case of the SQL Server browser, we're going to have to enable certain ports to be used as well. So to do that, we'll have to configure some exceptions. If you're using Windows Firewall and Windows XP, you'll need to create an exception, and we'll show you how to do that right now. We're going to go to Start, Control Panel. We'll go to the Security Center, and this is just one means of getting to the Windows Firewall dialog box. There's a couple of other ways you can do it. We'll go to the Exceptions tab, and what we want to do, first of all, is add an exception for the SQL Server service itself. So let's go ahead and add program, and we'll click Browse. I happen to already have browsed to this directory. I happen to know that the SQL Server service on my particular computer is on the C drive under Program Files, Microsoft SQL Server, MS SQL 1, MS SQL, and in the bin directory. So I'll select SQL Serve R.exe and click Open and click OK. Now if I'm going to enable the browser service, I'll have to add an exception for that as well. So let's go ahead and click Add Program and Browse. And this time we're going to have to back up a little bit and go to the 90 folder, Shared, and SQL Browser.exe. So just to kind of show you the progression there, on my particular computer, it's C:/program files/ Microsoft SQL Server /90 /shared. In that directory, I'm looking for the SQL Browser.exe. And then I'm also going to need to add a UDP port. So we'll go and click Add Port, and we can call this whatever we want. And the port we need is 1434. So let's put that 1434 in the port number text box and select UDP and click OK. And click OK. And then we can close down our Security Center and our control panel. And now what we want to do is go to a second computer and try to access this instance of SQL Server using the Management Studio Express on that other computer. So let's do that right now. So now I'm looking at another computer on my network. Let's go ahead and open up the Management Studio Express. And I'm going to change from this, the default setting, which is the local computer, and we'll change that to the IP address 192.168.1.105 on my particular network, /SQL Express. We'll change from Windows authentication to SQL Server authentication. Recall that we created a login named Bob, and I'll type in the password now. Let me make sure I type that correctly. And then we'll click Connect, and with any luck, we'll connect over the network to our My Company database. where I am given the role, the DB owner for this particular database. I'm not the DB owner for the other databases on this network, and you can see as I try to access that I get it's not accessible because I don't have the proper permissions, the proper role to access that database. The last thing that I want to try to do is use the SQL Multi-Users VB application that we used a few moments ago and modify the connection string so that it points to the database on the other computer, the original computer that we were working with. So let's switch back to that computer right now. And what we'll do is we're going to need to change, for this particular database, we're going to add the user Bob and make him a DBO on this database as well. So we'll find him here and give him the ability to be the DB owner. I could also just give him one of the lesser responsibilities like data writer if I wanted to. That'd be fine. And now that I've made the login Bob a user on my SQL multi-user vb.mdf file, I'm going to go back to the other computer now and change the connection string to point to this database and log in as this user. So I'm back on the remote computer right now, and let's open up the config file. As a matter of fact, I've already got it open. And I changed the connection string. I changed a couple of things about it. First of all, I set the data source equal to the IP address / SQL Express, our instance of SQL running on that computer. I got rid of the DB attach name and instead used initial catalog equal and then the name of the database. Now in this particular case, the name of the database happens to be the path as well. We may need to go back and change that. It's usually bad practice to have that all laying out there. So we might go back to the other computer, change the name of the database so it's a little more friendly and less insecure by telling the exact path and the name of the file and so forth. And then I add in user ID or UID equal Bob and the password pwd equals the password. Now I can encrypt this whole connection string as well so as to make this non-human readable and therefore hackable, and may want to do that in the future. But for right now, we just want to test and see if this works. So I copied the SQL multi-user application just like I did in the previous example a few moments ago, copied it over to this computer, and you just saw how I changed the configuration file. Now let's simply just run our SQL multi-user vb.exe, and when we do, we get the data that you'll recall we saw a few moments ago whenever we ran this on the other computer. So it's taken a little bit of effort, but we were able to successfully enable concurrent multi-user access from different computers by simply making a few settings within the configuration tools, enabling communication through the firewall, and then making a change or two to our connection string within the application on a remote computer. Before we close, let's consider an ASP.NET application. Which of the scenarios is true for a web application? Is it treated like user instances or concurrent multi-user access? After all, you potentially have thousands of different users. Do you have to create an account in SQL Server for each one? Well, not exactly. While you may have a number of different people connecting to your web application, the web server software, Internet Information Services, uses a single Windows login to represent all of those users. So if you have developed a web application using Visual Web Developer 2005 Express Edition, and it utilizes a SQL Server 2005 Express Edition database, when it creates the connection string for you, it will automatically set user instance equal to true. In other words, there's nothing special you have to do within SQL Server or on your web server. It just works. Now, just one more thing to note. If you're just getting started, it can be a little confusing to differentiate your database's permissions, like we've been discussing for the last half hour or so, and your application's permissions. You may want to limit who can access certain web pages on your website, and you certainly can store those logins in a table in your database, the way you may have done if you've used the ASP.NET Web Configuration utility. and you saw how it created the ASP.NET db.mdf file in your project. But the way your application can check the table in your database to see those logins and permissions is by using a single Windows login account. So just note that limiting access to your database and your application are two totally different things. You can store your application's login information in a database, but only one Windows user can access that database. And as we close, I just want to reiterate that in most cases, especially as you're getting started, or if you'll be building small web applications that reside on a single server, you won't need to be concerned about some of this more advanced functionality that we talked about today, like multiple users on a single machine or multiple users on multiple machines. But I wanted you to be aware of how this works and demonstrate how SQL Server 2005 Express Edition can handle these different scenarios. Okay, so we're getting close to the end. Just one more video left in this series. In the next video, we're going to put all of this knowledge that we've gained over the previous 7 lessons together. We're going to build an entire application from scratch, so don't miss that one.